Hi, I'm going to calculate the dimensions or the power needed for this pump. Um, we are having 0.5 meters vertical, 2 meters in the outlet, and 100 meters elevating 30 meters, and 5 meters straight, and 4 meters vertical, and 2 meters straight. And it is going into the water tank here. It's 15 cubic meters, and the inlet pressure is 1 atmosphere, and the outlet pressure up here is also 1 atmosphere. The tubing is a 2-inch. So let's start. I'm going to add in some values here. We only have one compound, and that's water. And we're going to use the steam tables here. And as the units system, I use C5 here. Going to add a material stream. And we know that we're going to use 15 cubic meters per hour to fill the tank. So the flow is known, and we are having the inlet pressure of 1 atmosphere. I'll add a pipe segment, and we had half a meter of pipe to the inlet of the pump. And it was carbon steel. So I'll use carbon steel and 0.5 meters, and the elevation was 0.5 meters, and we had 2-inch pipe here. And I'll add an inlet, because that is also causing a pressure drop. We have the normal inlet here, and carbon steel, and 2-inch pipe. So let's see if that's okay. Yes, that's okay. We can now add a pump. We're going to add a separate energy stream. So now we are here at the outlet of the pipe. We're going to add the 204, 5 and 4 and 2 meter segments of pipe. Can do it here. And there was carbon steel, 2 meters, 0 meters in elevation, the tube diameter, and we had the 100 meters with 30 meters elevation, and the tube pipe diameter we have the 5 meters, and 0 meters in elevation. So we are now here, we are going to the vertical segment. Carbon steel still, 4 meters in length, 4 meters in elevation, and the pipe diameter. And then we have to add the last 2 meters of pipe. with 0 meters in elevation and the tube diameter. So, and we had also to add an outlet. Because that is also giving some pressure drop. So we also have some elbows. I'm estimating this to 45 degrees. We have 2 pieces of the 45 degrees elbows and 2 90 degrees elbows here. I will add them. 45. 2 pieces of them. And 90 degrees elbows. We have here 2 pieces, them, and carbon steel, and the diameter 2 inch. So, and we are going to solve it. Or we can have a view here to see is it looking okay? It is looking okay. Yes. We're getting a notice that we have a negative pressure. That means that we have our pump don't give any pressure. Can we see here what? No, we don't have any indication of how low, but we are going 30 meters up. It's at minimum 3 bar. Yes. But we don't have sufficient pressure here into the tank. Oh, we're going to add a tank. And it's 15 cubic meters. Hey, what happened to the flow? Oh, we're having 15 cubic meters in flow rate per hour. So now it went red here again. Okay, negative pressure. The 3 bars wasn't enough. We can try with 4. Okay, 4 is enough. Quite enough. It's only used a 0.72 bar, and we know if we're going into an open tank, it has atmospheric pressure. I'll add a logical block. It's a controller block. I'll say, okay, what are we going to adjust? We're going to adjust the pump. It has number 6 here, and the pressure increase. It's the 4 bar, as I set it to in the start. And we are having number 11, and we're having the pressure that we're going to adjust, and we're going to adjust it to 1.013 or 1 atmosphere. So okay, we're using a controller block, going to adjust it, and now we have the 1 atmosphere in pressure, and we can see we're going to use 2.38 kilowatts to our pump with an efficiency of 75%. We are having NPSH of about 9.35 meters. we could just try to change to 60% in efficiency. And we can see we are going up to almost 3 kilowatts. So DWSim has some curves we can edit and put in, and if we have an actual pump, we can put in the head, the power consumption, the efficiency, the NPSH, so we can avoid cavitation in the pump and so on. But this is just the raw calculation, what's needed based on the efficiency here. So that's it. Thank you for being so far into this tutorial.